All right, Mr. Alvarado, you did a really nice job on this challenging test. A couple things I wanted to point out. For this number one, you got the right answer. It was one, but you multiplied it out. You said 2 times 2 is 4, and then you said 2 to the fifth is 32. And what you could have done is realize that 2 to the second here would cancel out with this 2 to the second because this is in the numerator, this is in the denominator. And when you have the bases are the same and you can subtract the exponents when one is in the numerator, one's in the denominator. And same thing with this one. 2 to the fifth would cancel out with 2 to the fifth because, again, 2 to the fifth is in the numerator, 2 to the fifth is in the denominator. You could cancel them out. You could have also realized that there's really 2 to the seventh in the numerator because you can add the exponents when you're multiplying, and there's 2 to the seventh in the denominator. So if you have 2 to the seventh divided by 2 to the seventh, the bases are the same. You can subtract the exponents and get 2 to the 7 minus 7, which is 2 to the 0 or 1. And that's important because if the bases were bigger, or if the bases were variables, like x to the second and x to the fifth, and so on, you would need to be able to figure that out without being able to multiply it out. So that's the first thing. Number two, you did well. Number three, you got the answer. You did a very nice job. You realized that you can just subtract the exponents, 7 to the fifth and 7 are basically cancel out to 1. So you knew it was 10 to the ninth or a billion. But you wrote there's a billion more atoms. But since you divided, you should say there's a billion times more atoms. Um, Not just you added a billion and get the answer, but you multiply by a billion. So in other words, there's a billion times as many atoms, not just a billion more atoms. And that's a big difference, right? Like if I said something is 2 times as big, that's not like saying it's 2 more, right? So saying times as big is what you would do when you're dividing here. So that was for number three. Number 4A, perfect. You realize the exponential growth here. But 4B um, was actually a linear situation. So it says the annual food supply of Oz is currently sufficient for a population of 700,000 people, and the food supply is increasing at a rate which would be 10,000 people per year. So what you should have written is 700,000 as the y-intercept where you started, plus 10,000 times x. So this would be a exponential growth, and this would be a linear growth, which would change some of these answers down here. And then the last thing I wanted to point out was I did a really nice job with number 5. I was just interested in how you figured out that C was 8 hours. I think that's right, but I'm just interested in how you figured that out.